Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss units of rate of a reaction. Units of rate of a reaction. Last class I have started new chapter, that is the chemical kinetics, and I have discussed many things, fundamentals about the chemical kinetics, and also I have discussed rate of a chemical reaction. In that I have discussed what is the rate, what is the concentration, all things I have discussed, and also I have discussed that rate in terms of reactant and rate in terms of product. As for example, I have discussed, suppose balanced equation is there, A plus B, that is giving C plus D, then rate of reaction in terms of A, in terms of B, or in terms of C and D. I have discussed, means in terms of reactants or in terms of products. And also I have discussed that suppose balanced equation is a small a and capital A plus a small b capital B, that is equal to a small c capital C plus a small d capital D. Suppose this is the balanced equation. Then in this type of situation, what will be the rate of reaction in term of A, B, C, D? Then here you can write coefficient you have to consider, coefficient. As for example, for capital A small a is the coefficient, also called stoichiometric coefficient. For the B, a small b. For the C, a small c. For the D, a small d. These are the coefficient. Then you know that in the in the term of reactants, their concentration decreases, and in the product concentration increases. That's why rate of reaction in terms of A, B, C and D, you can, last class I have discussed, again I am in general way I am telling you, then I will come to the new things what I want to tell you. Unit of rate of reaction I will discuss, but first these important things I want to tell you. Then a small a, this is the coefficient of A, reactant A, capital A, like that way. B, a small b is the coefficient for capital B, reactant B, and a small c is the coefficient for capital C, means reactant C. A small d is the coefficient of D, means reactant D. Then for this type of reaction in general way, you can write, because in the term of reactant, their concentration decreases with time. That's why minus term you will use, means minus dA upon dt, a small d differentiation, dA upon dt, t is time, then dA upon dt, that is the rate of reaction in term of A, Then now exact rate of reaction, for that you have to consider the sign. Then minus dA upon dt, that is equal to minus dB upon dt. Both you have now you told about the in term of reactant A and B, but here coefficient also you have to consider. Then for that, for a small a, you should write 1 upon a. Before writing dA upon dt, you should write 1 upon a small a. Means rate is equal to minus 1 upon a, dA upon dt. That is equal to minus 1 upon b, small b, dB upon dt. Both are equal. Correct? Because A and B both are reacting. Correct? Hence both will lose the original concentration. There will be decrease in original concentration. Correct? And coefficient you are writing down 1 upon A or 1 upon B. Why? Because that also you have to consider. Then simply you can tell that this for dA upon dt, that is for you can say 1 mole only. 1 mole only. Correct? dA upon dt, if you are writing rate minus dA upon dt, that is for 1 mole. 1 mole of A. If suppose 2 mole is there, then what you will write? Then for 2 mole, what you will write? This is for d upon dt. Then you can write if mole is 2, it means concentration is increasing. 1 mole and 2 mole. Because now concentration is more, hence rate of reaction will be more. Correct? Then here in that situation, rate will be faster than 1 mole. But here what you will write? You want to know the rate. Then for 2 mole, rate is more. Then for 1 mole, if 2 mole rate you are knowing. If for 2 mole, what is the rate? Suppose X. This is for 2 mole. Then for 1 mole, how much? X upon 2. Correct? Because now you are considering for 1 mole. Hence, in a balanced equation, if 2 mole, 3 mole is written, then obviously when number of moles are more, then rate will be more. Correct? Then if you want to consider for 1 mole, then you have to divide by coefficient. Means for 3 mole, suppose rate is X. Then for 1 mole, X upon 3. Like that way, if a small a is the coefficient, for a small x, a small a coefficient is there, then for that some rate is there, then for 1 mole, rate divided by small a. That's why always coefficient you are writing down. 1 upon A, 1 upon B, 1 upon C, 1 upon D. Correct? With rate, whatever rate is there, just there down you write A. Means 1 upon A, D upon dt. That is equal to 1 upon B, dB upon dt. That is equal to 1 upon C, dC upon dt, and again 1 upon D, dB upon dt. Correct? But only sign you have to consider. For the reactants, minus sign, and for the product, plus sign. Then minus dA upon dt is equal to minus 1 upon B, dB upon dt. That is equal to plus now we are writing 1 upon C, dC upon dt. That is equal to minus 1 upon D, dA upon dt. Correct? This is very, very important concept. I told you all four are equal. Because when A and B will react, only then C and D will be formed same time. Then this A and B both concentration is decreasing, and C and D both concentration will begin to increase from the zero level only in the same time. That's why you are dividing by always dt. These are the here also dt, there also dt. Reactant side dt and that side also dt. And per mole you are considering, per mole rate you are considering. That's why you are dividing by coefficients. You are dividing by coefficient because A, B, C, D may be any molecule. A may be 2, B may be 3, C may be 4 and D may be again 1, like that anything. Whatever you divide by, if you divide by coefficient, then per mole. Then per mole rate will be equal for all reactants and products. I think now we have understood. Then simply you can write all rates are equal. Only for the reactants minus sign you have to use for both reactant, and for the products, if two products are there, then your plus you have to write. For the products plus, for the reactants minus. Correct? And rate is equal to, rate is equal to concentration divided by time. Simple concept. Rate is equal to concentration divided by time. Per unit time, what is the change in concentration? Change in concentration. Okay. Per unit time, that is the rate. That's why dx upon dt you are writing. Then now you are knowing that also concentration is equal to mole per liter, mole divided by liter, mole per liter. Correct? In the beginning, you can say in 1 liter 1 mole was there. After some times it became half mole or 0.3 mole, 0.2 mole per liter. Then now it decreased. Then in that way you have to think. Then now I am coming towards unit of rate of reaction. This is very, very important. In all examination, this question is asked. What is the unit of reaction? Then here, unit of the rate of reaction. Then rate rate of reaction. Rate, now formula, concentration divided by time. Concentration divided by time. Hence, its unit will be concentration. Time generally it is taken in second. Time is taken in generally in second. But here I am telling in general concentration per unit time. That is the unit. Concentration T minus 1. Concentration T minus 1. That is per unit time. Concentration per unit time. That is the general way you can write the unit. This is actually way to write the unit. Then for concentration divided by time, then you can write concentration T minus 1. Then now you can write what is the concentration. Then concentration is equal to mole per liter. Mole divided by liter. Hence you can write in the place of concentration mole divided by liter time inverse. Time inverse. Correct? Then mole per liter, again you can write mole liter minus 1, mole L minus 1, and already T minus 1 was there. And now this is the, you can say, way to write the concentration. Mole per liter per unit time. But time generally will be in second. Then now correct way, unit will be mole per liter per second. mole per liter per second. Okay, don't forget, better you keep in mind concentration divided by time, that you keep in mind. After that you put the value of concentration whenever you require. Concentration, you know, mole per liter. Mole per liter. Mole per liter, you can write mole L minus 1. Then now put the value there, you will get the unit. Then mole liter minus 1 means per liter. Time per unit time means mole L minus 1 T minus 1, a small t. Correct? This is the way to write. Or you can tell mole per liter per second. Mole per liter per second. Then this is the way to represent the rate of the reaction. And rate of reaction actually vary according to the what type of reaction is there. Reaction may be zero order reaction, first order reaction, second order reaction. Third order is also there, but rare. Yeah. Then zero order, first order, second order. Or directly you can tell nth order, a small n, nth order. Nth order means what is the value of n? Maybe 0, maybe first, maybe second, maybe third. But second onward only reaction will be less and less. Third order is rare. Third order of reaction is rare. Then for each order, rate unit will be different. Rate of reaction for each order will be different. Then obviously unit will be also different. That also I will discuss. Then last class also I have told you can these things represent the rate of reaction by diagram also, by plot also, by graph also. Means how concentration versus time, concentration y-axis and time on x-axis. Correct? Then in case of reactants, in term of reactants, that you will get a curve, inner curve you will get, and in the case of product, outer curve you will get. Correct? Because that is the plus, that their concentration will increase, that's why outer curve, upward curve, and in the term of reactant, downward curve. There already I will sent last class a diagram for all the things. Then now one numericals I am telling you, it is very easy only to understand the concept. That numericals I am telling you. Quickly I think you will solve it. Question I am telling you, from the concentration of C4H9, that is the butyl chloride, from the concentrations of butyl chloride, its formula is C4H9Cl, butyl chloride, at different times given, they have given below. Okay, calculate the average rate of reaction. Okay, whatever I have told you, that is the rate, that is the average rate. Okay, rate you can tell average in the term of average rate, differential rate, instantaneous rate, correct, integrated rate, all are the way to tell the, to represent the rate. Then average rate, just like average term is the same, average speed, average velocity is different, speed is the average. Okay, then here you have to calculate average rate. Time is given, and with the time what was the concentration, this is given. Okay, I will tell all this about all this rate, but now this numericals now, just to see, they have given reaction is given, butyl chloride plus H2O, it is forming ethyl alcohol plus HCl. You have to calculate the average rate of the reaction during different interval of time. Means at different time they have given what will be the rate. You know that with the time concentration change, the rate will change, concentration is changing, and the rate will change. Then you have to calculate that rate. That rate is called average rate. During that period, rate will be same. Then data is given, that is time per second. Time per second. Time they have given in second. Then 0 time, 50 time, 100 means 0 second, 50 second, 100 second, 150 second, 200, 300, 400, 700, 800. At this time, what is the concentration? It is a given concentration of butyl chloride. Mole per liter, it is a given. Then at 0 time means a starting time, when you started, that time concentration of butyl chloride was 0.1, 0.100 or 0.1 also you can tell. And after 50 second, concentration became decreased 0.0905, and 100 second, at 100 second, now again decreased, concentration decreased. They have given 0.0820. At 150 second, concentration is given 0.0741, means decreased. Again at 200 second, again decreased 0.0671. 300 second, again decreased 0.0540. Again 400, again decreased 0.0439. 700 second, again decreased 0.0210. 800 second, again decreased 0.017. 0.017 means with the time concentration decreased. Then you have to calculate rate of reaction. Rate of reaction. Then now easily you can calculate. Then for that what you require? You require change in concentration. Correct? You require change in concentration and change in time. Then at 0 concentration, at 0 time, what was the concentration? Then 0.100 in the beginning. After 50 seconds, its concentration is 0.0905. Then difference of time is 50 seconds. 50 minus 0 means delta T is equal to 50. And this concentration, change in concentration, delta or d, small d also you can tell, d, small dt, small dt you can tell, or small change in dx you can tell, dx, change in concentration. Then what is the change in concentration? In the beginning it was 0.1, now it became 0.0905. Then this difference easily you can know. Then rate is equal to what? Rate is equal to what? Change in concentration divided by change in time. Change in concentration divided by change in time. Then after putting the value, you can get the result for all. Then that at this you calculated when it was at 50 second. Now 100 second, then again same way, 100 minus 50, 50 second, and at 100 second concentration is 0.0820, and 50 second 0.0905. Then now what is the difference? Then again 0.0905 minus 0.0820. This is the difference. Correct? Or final minus initial you will do, then you will get the difference, but value will be in minus. But that is the correct way. Final minus initial. Correct? That value will come in minus because the time it is decreasing. Time is increasing, concentration is decreasing. Then this time also time is 50 seconds and change in concentration, easily you can calculate difference. Then again delta x minus delta t, you put the value, you will get the result. Like that way. Third 150, it will now at 150, that 150 minus 100, then time is again 50 seconds, 150 minus 100, and concentration again from 0.0741, from 0.0820, now it become 0.0741. Then here you can again, you will get result in minus. Then again delta x minus delta t, delta x divided by delta t, easily you can calculate. Then like that way you can calculate for all, for at different time you can calculate. Correct? Then actually by making a table also you can calculate, because 6-7 data are there. Then one column you can make for the mole per liter. Butyl chloride concentration, first write they have given 0.1, 0.0905, third is 0.0820, correct, fourth 0.0741, fifth 0.067, like that way for one column in make for the mole per liter. And already question they have given concentration at this time. What was the concentration in second column you can write when you tie these things. Concentration they have given at 0 time, 50 time, means you can make columns. Then and after the putting the value you will get the result. Then 0, 50 means 50, that you will put the value what I told you, that way you will get different rate of reaction. In the first case means when time was 0 to 50, at 50 seconds you will get d minus dx upon dt, then that will be value will be 1.90. And when it will be from 100 seconds, for 100 seconds, then 100 minus 50, that time value will come 1.70. When at 150 minus 100, then you will get 1.58. Like that way 200, the 200 minus 150, then now you will get that time 1.40, because molar concentration value you have to just difference you have to find out. Then 300 minus 200, now 100 second difference is there. Then this time it will come 1.22. 400 second, 400 minus 300, then that time will get 1.10. And again 500 minus 400 means 500 second, then again it will decrease 1.04. 800, then 800 minus 700. Okay. And then like that way you can calculate always dx upon dt, means the difference of concentration divided by time, change in time. Okay. Now already this discuss about the rate, instantaneous rate. Now I want to tell about the instantaneous rate. How we will calculate what is actually instantaneous rate? Then you should understand. Instantaneous rate means, see, average is different. As for example, now you have seen up to 50 second rate was the same. From starting to 50 second rate was during this period rate was same. 50 to 100 second, rate was again same. And 100 to 50, again rate was same. Means this data, now I solve the numericals. In that you have seen that in the beginning 0 to 50 rate was 1.90, and 50 to 100 1.70, 100 to 150 1.58, means it was decreasing. Then at this range of time, means 0 to 50, rate has not changed. Average rate, that is called average rate, correct? 100 to 50, 150 to 200, 200 to 300, like that way. During that period, rate was same. That is called average. But if you want to know at a particular time, suppose you want to know 56 second, 102 second, 105 second, 140 second, exact, particular, fixed second, then that time what is the rate? That is called instantaneous rate. Instantaneous. INSTAN, instant, INSTANTANEOUS, instantaneous rate. Instant, first you write instant, INSTANTANEOUS, instantaneous rate. Means at a particular second, what is the rate at that time? Then that how will you get? Then you can get only by graph. Then either in term of you can say reactant or product, means upward or downward curve. Any curve you can use at that moment. Suppose 600 second, what was the rate? 205 second. Then in the graph, you will draw the graph, because data will be given. In this example only, what I discussed, you can draw the graph. Time versus concentration. Time x-axis and concentration y-axis. You can draw a graph. Then it will come as a curve, downward curve. Then now at a particular time you want to know. Then by the time, means x-axis you see where is the time. Suppose 210 second as for example. Then 210 second on x-axis time is there. Then 210 second, there you mark it and go up. What was the concentration? Means if you go up, then actually curve is there, it will touch the curve. If from that time on the x-axis you mark time and go up parallel to y-axis, and then automatically it will touch somewhere on the curve. Then what you have to do, that where it is touching, that point, mark it one point where it is touching. Then now from that point, just you can make these things from that point parallel to x-axis, a draw line. You can draw a line. Then obviously it will become, you will get a right angle triangle. Okay. Then like that way, right angle triangle, if you will get, then by using that way you can get the exact that at that moment what was the concentration, and concentration divided by time, that is the rate. Then that time concentration you will come to know, and time also you are knowing. Then concentration divided by time. Then at that moment, what was the rate? You can calculate. Correct? Then I have told you this is the instantaneous rate. Now I want to tell you other things. Actually, this is there example. By example, in a general way, I have told you about the rate in terms of reactants. Already I told you rate in terms of reactants, like A plus B, that is giving C plus D. Now example I am telling you, direct example, exact. Suppose 2HI is 2HI is giving H2 plus I2. 2HI gas, hydrogen iodide, it is giving 1 mole of H2, 1 mole of I2. Correct? Then what will be the rate of reaction? Then it is very easy, because now you are knowing reaction they have given 2HI. It is in gaseous state, small g, and it is giving two product, H2 gas and I2 gas, means vapor. Then now what will be the rate? Then by seeing the equation you can tell, rate expression you can write. Then rate of reaction will be what? That is the, in the term of HI, then DHI or delta HI divided by delta T. But here we have to main focus is 2HI is there, then 1 upon 2. We have to write 1 upon 2. Means rate of reaction in terms of HI is equal to half delta HI divided by delta T, or DHI upon DT. Half you have to write, and minus sign you have to write. Mean minus half delta H upon delta T. Okay. Now that is equal to, in term of product, it is giving two product, H2 and I2. Then for H2, now what you will write? That is delta H2 divided by delta T. Delta H2 divided by delta T, and sign will be plus. Then this is the rate in terms of hydrogen gas. Okay, and now these both rate will be equal. Rate in terms of HI, rate in terms of H2, both will be equal. Only difference that HI is in minus and H2 is in plus. Plus means delta H2 divided by delta T. H2 should write in bracket, big bracket, and that is equal in terms of iodine, I2 vapor. Then again same way, delta I2 divided by delta T. But here, because only 1 mole is there, coefficient is 1 mole, then if you write down 1, then right or not right, same thing, same meaning. 1 upon 1 means what? For both plus you have to write. For this product, 1 upon 1, 1 upon 1. Then 1 upon 1 means what? 1 only. Hence plus DH2 plus rate will be plus differentiation of H2 or delta H2 divided by delta T. Delta T, that is equal to plus delta I2 divided by delta T. Then now all rates are equal, means all three rates are equal. Minus delta HI or minus delta HI upon delta T is equal to plus delta H2 divided by delta T, that is equal to plus delta I2 minus divided by delta T. All rates are equal. Okay. Another example I am telling you, that this 5-bromide ion, okay, 5-bromide ion plus BrO3 minus bromate ion plus hydrogen ion, means 6H plus, reaction is given actually. 5Br minus plus Br3 minus plus CXH minus, and it is giving two product 3Br2 plus 3H2O. Suppose this is the reaction, then what will be the rate in this case? Again I am reading this, telling the reaction. 5Br minus plus BrO3 plus 6H plus, product is 3Br2 plus 3H2O. Then now we have to write the rate. Then very easy, rate is equal to, there are three reactants, then all three reactant rate will be in minus. Then minus coefficient is 5. The main thing is coefficient. The coefficient for bromide is 5. Hence minus 1/5 delta Br upon delta T. Okay, delta T Br means molar concentration, change in molar concentration of bromide ion divided by delta T, means delta Br divided by delta T. Before that 1/5 you have to write, means 1 minus 1/5 delta Br divided by delta T. This is in terms of bromide ion, that is equal to now bromate BrO3. Then now no coefficient, means 1/1. 1/1 means 1 only, minus delta Br divided by delta T, and that is equal to third you can say reactant, that is the 6H. Then now minus 1/6 delta H upon delta T. Now product side, that is the 3Br2 plus 3H2, coefficients are 3. Then now these two will be in the term of positive. Then you will get that is equal to 1/3 delta Br2 divided by delta T, that is equal to 1/3 delta H2O divided by delta T. All rate are equal. If one rate you are knowing, you can know other rate. All rate are equal, only coefficient you have to divide it by the coefficient. Only that things you have to, rate you have written, but coefficient you have written down, only then it is becoming equal. If you will not write the coefficient term down, then you can't tell, it will be wrong. You have to divide by coefficient, means per mole you are talking for reactant and product. Dividing by coefficient means you are talking about per mole. Okay. Then this I have told you about the distance rate. And if gaseous reaction is there, then you will use the term atmospheric pressure, partial pressure. Okay, in terms of gas, you will write partial pressure. Partial pressure, that time you have to use. One numericals I am telling you, that is for this understanding purpose, because this chemical kinetics chapter, that what you can tell, chemical kinetics chapters, without the numericals, this chapter will not complete. Full of numericals. Every question I am telling you, only numericals they will ask from this chapter. Thermodynamics also, all physical chemistry portion, and thermodynamics, chemical kinetics, and properties of dilute solution chapter, full of numericals. All physical chemistry means numericals only. You can't hope for the theory. Theory they will ask, suppose 10 questions they have asked, or 15 questions suppose it is asked, then out of 15, 1-2 questions may be of theory. Rest will be of numericals only. Hence no compromise on numericals. You have to you have to make up that if you are studying physical chemistry, then you should be mentally prepared for numericals. And to make the numericals easy, your concept should be very clear. And to clear the concept, you have to understand now, means when you are learning, that time you try to understand very clearly by some examples. Okay, then without that you can't solve any numericals. 100% it is correct. If you are understanding the subject matter, theory is clear, only then numericals will be clear. Now I am reading the question. And one more thing I am telling you, without physical chemistry, you can't compete any examination, medical, engineering, mains or advanced. No, if you want to get good rank, then without this it is not possible. Without numericals, you can't qualify. Only by some theory, how much marks you will get? How much marks? Hardly you will get 30% mark. Then what rank you will get? That's why this concept should be clear. Then if concept is clear, then you can solve the numericals. And the concept is clear, then in real life, when you will join the any, you can say, job, in a engineering job, medical field, any field, then that time this concept will be helpful, useful. Okay, then now I am reading the question. Okay, try to understand, then quickly you will solve the numericals. The decomposition of N2O5 means N2O5 pentaoxide, nitrogen pentaoxide, N2O5. The decomposition of N2O5 in CCl4, carbon tetrachloride, at 318 Kelvin has been studied by monitoring the concentration of N2O5 in the solution. Initially, the concentration of N2O5 is 2.33 mole per liter, and after 184 seconds, after 184 minutes, it is reduced to 2.08 mole per liter. The reaction takes place according to the equation. Equation is given 2N2O5. N2O5 is a gas actually. G you can write. 2N2O5. It is giving two product. 2N2O5 after decomposition, it is giving two product. 4NO2 plus O2. Means all are gaseous. 2N2O5, it is giving 4NO2 plus O2 gas. Okay. Calculate the average rate of this reaction in terms of hours, minutes and seconds. What is the rate of production of NO2 during this period? Because it is giving nitrogen dioxide, then what is the rate of production? Rate of production of NO2? Only they are asking NO2, not oxygen, only NO2. Oxygen is also the product, but they are asking only for NO2. Rate of production of NO2 during this reaction. Then now see, now actually you are able to solve the problem. This problem you can solve. This numericals you are in a position to solve. Then why I am telling? Because now you have to calculate the rate. Calculate the rate of this reaction in terms of hours, minute and second, whatever be, that is the different thing. Rate you have to calculate. And second things you have calculate, what again rate you have to calculate, what is the rate of the production of NO2. Means only rate you have to calculate. Then formula should be in your mind. Formula should be in your mind, only then you can think over. Then rate formula you know, for the product, for the reactant minus term you will use. Rate is equal to minus first to write, and then change in concentration divided by change in time. This concept only. For both, for product also, only plus sign will be there. This formula only you have to use. Then now you will think, you have to see the equation, reaction, given reaction. That coefficient you see 2N2O5. This is the reactant, it is giving two product 4NO2 plus O2. Now coefficient you have to keep in mind. Only for that purpose this question has been given. Then you want a change in concentration, change in time. These two things you want. And if coefficient is there, that you want to know. Then coefficient is very well clearly given. Okay. Then rate is equal to what? For N2O5 first to calculate the rate. Then average rate, that is it will become half 1 by 2 minus change in N2O5 concentration, change in concentration of N2O5 divided by delta T. Correct? Then minus you can keep outside, minus half, minus is there, no problem, half, and N2O5 concentration change, then they have given. In the beginning what was there, and after 184 minutes what was there, that both it is given. Then 2.08, in the beginning it was 2.33, and after 184 seconds it became 2.08. Okay. Then minus already you have written, no problem. Then final minus initial you will write. Then because it is decreasing, then the result will come in minus. Then already minus you have written in the front. Then what is the difference? Only that you write. Then 2.08 minus 2.33. If you will not write minus in the beginning, then obviously it will come, result will come 2.08 minus 2.33, result will come in minus. But already you have written minus term in advance as a formula, then only difference you write, 2.08 minus 2.33. And time, what is the time? Then 184 it is given, after 184 minute. Then now all things are knowing. Coefficient was a 2, the 1 by 2 already written. Concentration, change in concentration you have written. Time you have written. Then what is the problem? Only you have to simplify. Then after simplification, result will come per minute. Or also concentration, if you will write this thing, mole. What was the mole? Mole difference. Or finally in the end only you write the unit, better. Then now after solving, you will get 6.79 into 10 to the power minus 4. 6.79 into 10 to the power minus 4 mole per liter per minute. Because concentration, for the concentration what you will write? Mole per liter. Mole per liter is the concentration. Then wherever change you are writing, change in concentration, the concentration unit is mole per liter, mole divided by liter. Then mole per liter you have to write, because it is upside, and down is time, means minute, then per minute. Then unit will be 6.79 into 10 to the power minus 4 mole per liter per minute. Then now per minute this is the rate. Then you can easily calculate in second also and hour also. Per minute. then easily you can convert it into the this thing, hour also. Then how will you convert into hour? Minute you are knowing, per minute means 1 minute. Then in 60 minutes, multiply by 60, that is the per hour. After multiplying, that will become per hour. Then just you multiply by 60, then you will get the result 4.07 into 10 to the power minus 2 mole per liter per hour. Just you have to multiply, because 6.79 roughly 7 you can tell, 7 into 6, 7 into 6, what will happen? 42. Then it is coming around 4.07 into 10 to the power minus 2 mole per liter per hour. Okay, then this is an hour. Now if you want to know in second, then again a minute you are knowing, per minute you have calculated. Then that is in 60 per minute, means in 60 second you can tell. That's why if you want to calculate per second, then divide it by 60. What you got the value per minute, divide it by 60. Then you will get the result 6.73 into 10 to the power minus 4 mole per liter. You have multiplied, divided by 60. Then after dividing, because 6.79 is there and you are dividing by 60, then it will come 6.7, means around 7 you can tell, 7 by 6, 1 point something. Then exact result is 1.13 into 10 to the power minus 5 mole per liter per second. Actually, you make habit to get just to calculate in mind, rough, at least first to calculate. Then in a question they will give, because multiple choice question, then you will get idea, quick idea will get. Just you convert in the round figure all values, and then you will get rough idea. Then after that you can rough sheet is there, will in the end. That in shortcut way you can calculate. Then sometimes this rough calculation will help you. Then this you have calculated, rate you have calculated in terms of hour, minute and second. Now second part, what is the rate of production of NO2 during the reaction? Then now it is very easy to calculate. For this, rate is equal to what? Rate of production they are asking. What is the rate of production of NO2 during the reaction? Then here rate is equal to, same way you can write 1 upon 4 plus sign, because we are talking about the product. NO2 is product. Then 1 upon 4 delta NO2, delta NO2 divided by delta T. Then NO2 divided by delta T. Then its rate, if you will calculate, then its rate you have calculated already. This after putting the value NO2 production, NO2 production in the term of NO2, then 1 upon 4 delta NO2 divided by delta T. Then all rates are equal, you know, all rates are for the product and reactants, all rates are equal. Hence you can write 1 upon 4 delta NO2 divided by delta T, that is equal to what you have calculated first time per minute. In case of N2O5, same will be the rate, Then per minute you have calculated in the beginning 6.79 into 10 to the power minus 4 into, here one thing I want to tell you that There you have calculated 6.79 into 10 to the power minus 4, okay, mole per liter per minute. Correct? This you have calculated in the beginning, first time only. Then this is the value 6.79 into 10 to the power minus 4. The 4 mole per liter per minute. This is the, you can say, rate of. This is the rate of, and this value is equal to, this value is equal to 1 upon 4 NO, delta NO2 divided by delta T. This value 6.79 into 10 to the power minus 4. This value is equal to 1 upon 4 delta NO2 upon delta T. Then what is the value per mole? This is the value of 1/4. This rate is for 1/4. Then for the 1/4, when concentration was 1/4, then this was the value. Then for 1 mole, it will be automatically, it will be multiplied by 4. For 1/4, this is the value. Then for 1, how much? It will be more. Means you have to multiply by 4. Then that is the rate of production they are asking. Then production asking means per minute they are asking. Per minute. Then you have to multiply by 4. This is the rate of production. But other cases, simply you have average rate you have calculated. Okay, in the beginning what you calculated, that was the average rate. But here now you have calculated, that is the rate of production. Okay, then that was for that is for 1/4. This value this is the value, because what you have calculated for all 1/2. In the beginning calculated minus 1/2 this time, that is for that rate is also for half, 1/2. That average rate you have written, that is also for half mole. If you want to know per mole, then you have to multiply by 2. But okay, their average rate you have asked. Okay, you have calculated average rate. Then now you have calculated the these things, rate of production. If a question is asked, calculate average rate, then just simply you can coefficient to write down for average rate, But for production, if it is asked rate of production, only rate, then for you have to calculate for 1 mole. Okay, then now you have multiplied by 4, because this value was for 1/4. Then for 1 mole you have multiplied by 4, then that is a per minute. Okay, if you want, you can calculate per hour also, per minute, per second also. Then this I have discussed about the these things, unit and this numericals I have discussed. Okay, because this is very, very important. And now these things I want to discuss now these things, factors influencing rate of reaction. Then here you know that rate depends upon concentration. If concentration is less, rate will be less. If concentration is more, then rate will be more. Okay, the rate of chemical reaction at a given temperature may depend on the concentration of one or more reactants and products. The representation of rate of reaction in terms of concentration of the reaction is known as rate law. That is called rate law. Again you listen that reaction in terms of rate of reaction in terms of concentration of the reactants. Correct? Rate of reaction in terms of concentration of reactants is known as rate law. Okay. It also called rate constant or rate expression. Three terms are there, all have same meaning. Rate law, also called rate constant or rate expression. Okay. Rate of a reaction depends upon the experimental condition. Keep in mind. Rate of a chemical reaction at a given temperature, already told, depends upon concentration. And other things I am telling you, rate of reaction depends upon experimental condition. And experimental condition, as for example, concentration of reactants, pressure if it is a gas, and other two are there, temperature and catalyst. Four things. Rate depends upon four things: concentration, and if it is a gas, then you can tell pressure, and after that you can say pressure. Actually, pressure term you will use only for gas, and concentration term you will use for the liquid solution. Both are equivalent term. Mole per liter, that is concentration, and partial pressure. In the place of concentration you can write partial pressure. And after that, important factor is there, temperature and catalyst. Then actually today I am stopping only here. I will derive, actually I have to derive the these things, some expression. Then today it is not possible. Okay, it will take more time. Then I am stopping only here. Next class I will continue. Thank you.